Hi everyone, my name is Lydia and this is what I wish they told me about econometrics and introduction. In this video, we're going to read a real STATA regression output line by line, and the goal here is not to explain every number mathematically, is to understand what kind of information each part is giving us. This is so that you're sure not to be overwhelmed by the numbers that will appear in your regressions. So on STATA, this is what a regression output would look like. I have used one of the data sets already available in STATA memory. And this is something that you can produce yourselves as well, which we'll see in another video. But for now, let's concentrate on the block of numbers and what each of these blocks tells us. Starting from the very top, you're going to see this line that I have included, which is based on the regression that we just ran. In any software, usually the format is that you put the y variable first and then all the x vars right after it. So if we were to refer back to the previous video on the blocks of questions that we are answered through a regression output, in terms of like which are the relationships that we are trying to estimate in here, it's clear that we're trying to see the relationship between price and all of these other variables in here, which, since I have used the auto data set, are how different characteristics of a car affect the price of the car. So outcome variable price, and the rest are your x variables, or your regressors. Let's move on to the next block of information. You will see this entire block in here where we got source and you've got SS, DF, MS, you've got model, residual, total. So on top of numbers, we can see that we also have some words in there. So SS is short for sum of squares. DF is degrees of freedom. And MS is mean squares. And the source here is basically telling you where the sum of squares, or like the sum of squares from the model, from the residual, and the total sum of squares. This block describes how variation in price is being decomposed. So this is not yet information on how individual coefficients are estimated. This is just on how the variation in price is being decomposed. We will return to this block in a dedicated video. For now, just recognize that this is about model fit and not interpretation of the coefficient. So this is more your last block, block D. Okay. Then moving to the right, we have another block of numbers in here. And some of these numbers are very self-explanatory. So for instance, we have number of observations, that is 74. We have an F statistic with its corresponding p-value. We have the R squared and adjusted R squared. And we also have another information here, the root MSE. Keep in mind that, as we said, we're going to have some information that up until this point of the playlist, we haven't explained what they are exactly yet. So this video is just to point out the kind of information and not give you an intuition of like exactly what this is telling you at this stage. Just keep in mind for the F test that you have in this particular block in here is answering the question whether the regressors taken together explain variation in price. So it's a little bit of how good of a model you have constructed. So asking whether the regressors taken together explain variation in price. We'll come back later to the F-test. For now, just know that this is a model level test and not about one coefficient. Okay, so still that part or block D of information. I also want to point out, before we move on to the next block, that we have here this R square and adjusted R square. Although the names might look similar, they are telling you slightly like a different information because the formulas for each of them are slightly different. And in a separate video, we'll see why we need an R square and an adjusted R square. But for now, keep in mind when you just start with econometrics, the go-to number that you have to explain most of the times is the R squared, which tells you how much of the variation in price is explained by the model. Okay. Now, keep in mind, this is a misconception in general, but a higher R squared does not mean the model is causal or correct. Okay, so it only describes a fit. The last element of this block was the root MSE. It gives you the typical size of the residual measured in the units of the dependent variable. So typical size of the residual variable. Again, we'll unpack the root MSE properly later. So for now, think of it as a typical prediction error. Okay. And finally, we're moving to the last block of information that we have right here. You'll notice that the Y variable is given to you right in this box right here. Just a reminder that this was the dependent variable. And each line, remember, was a coefficient and its characteristics. So here, this is information on the miles variable. Here, information on the weight. And here, information on the estimator, whether the car is foreign or domestically produced. And lastly, the last bit of information, the constant that you see in here. This is your intercept. This is basically your beta null or your alpha, as you've been calling it in the previous videos. Okay? And as we said, all the information regarding that particular estimation is in that particular line. So let's look at each information, at each bit of information that you have for each of these variables by now looking at the columns. So the coefficient column that we have in here, these are the actual beta hats. Okay, so the constant here would have been your beta 0 hat, while this would have been your beta 1 hat, beta 2 hat, beta 3 hat, and so on. Okay, so you get the actual estimated numbers. We're not going to stop on the actual interpretation of these coefficients in this video, but keep in mind that whenever you keep one of those numbers and you make an interpretation of them, you always have to say that it's an association, it's a correlation at that point. You haven't decided or proved yet that is causation. And it is done by holding the other variables here constant, okay? Keep in mind, this is an estimate and it's not yet a statement about certainty. The next column is standard errors. Standard errors. So you see the numbers, keep in mind they don't have a unit in there. it tells you how much this estimate basically would vary across repeated samples. And in this case, weight, as you can see, has a very small standard error, while the miles variable has quite a high like a standard error. So you can already make a few prediction or create certain expectations that something that has a small standard error is most likely going to give me a more precise estimate, while something that has a large standard error is going to give me a very noisy estimate. The next column is the t-statistic. And notice, this t-statistic can be calculated by yourselves as long as you have the coefficient and the standard error here. So notice that if you take the coefficient and divide it by the standard error, you are going to get exactly the same number that you have in this t column. Okay? And remember, the t-statistic compares the estimate to its uncertainty. So if you ever have exam or questions in exams or in assignments where certain parts of this table are erased and you'll have to find yourself what those numbers are, keep in mind there is a relationship already with the first three columns. If you wanted to find the t value, you need to know the coefficient and the standard error. If you need to find the standard error, it suffices for you to know the coefficient and the t-statistic, and you can easily find it from there. The next column, right after the t-stat, is actually the p-value. And keep in mind, this is the p-value that is actually associated with the t-statistic that you were given in here. Okay? Now, for the weight, as you can see, the p-value is essentially 0. Which, according to the interpretations that we've done in the previous videos, it means that it's very hard to explain by chance alone. And look here, it's very clear that the t should be a very high number. So if I were to construct a graph, just like we've done in the previous videos, so on that particular beta, if this was the 0, imagine, usually we end here with like 3 standard deviations. The 5.49 is actually going to be like very far here in the tail. So that's why the further away we are, the smaller the p-value that is associated with it. In this case, is like infinitesimally small, so essentially 0. For the MPG, the miles variable, you can see the p-value is actually quite high. So this estimate is well within what the randomness can explain or could generate. The last bit of information that you have is the confidence interval in here. Notice very carefully that in STATA, the default used is 95% confidence interval. Okay, so if you wanted to change that and have a 90 or a 99, then you would have to manually tell STATA when you run this command in here that you want the interval to be at a different percentage. Otherwise, the default is 95%. Keep in mind, this interval, so these numbers in here, you can also calculate them themselves now that you know the coefficient, which would be like the center, your beta hat, and then plus minus, you'd need the standard error in here, and in this case, the Z value for the 95%. Okay. Keep in mind, confidence intervals combine magnitude, uncertainty, and significance into a single object, as we've seen in previous videos. Ultimately, before we conclude this video, is just a quick reminder that although this constant is the last line, it's a very important element because that is your beta null hat, your intercept. Now, the interpretation of it, you'll see, will depend on the context, but sometimes it's beneficial, sometimes it's not. So most of the times you'll see not a lot of people concentrate too much into interpreting that constant. A very common mistake that is done when you read a table like this is that you read all the coefficients, then all the p-values. Don't do that. As I said earlier, read across each row. So each row tells a complete story of the estimate, the uncertainty, and the inference. So to close this video, remember, top panels, they are model fit and variation. Bottom, coefficient table, it's where your relationship and inference elements are. STATA output looks dense, but again, it's extremely structured once you know what to look for. Thank you for following this video, and I'll see you in the next one.